Chapter 3, Section 1, the derivative of a function. If y is equal to some function of x, we say the words, the derivative of y with respect to x, symbolized dy over dx, pronounced the derivative of y with respect to x. Another symbol for the derivative of a function is f prime of x. And here is the important definition. The derivative of y with respect to x is the limit of f of x plus h minus f of x all over h, where h is approaching 0, and the h is actually delta x, change in x. The word derivative of a function, exactly the same as the slope of the tangent line to the function, also referred to as the slope of the curve. And it's also called the instantaneous rate of change. Or to be specific, it's the instantaneous rate of change of y with respect to x. So derivative, slope of tangent line, slope of curve, instantaneous rate of change, all exactly the same thing. There's two definitions that are equivalent. We need to memorize both of them. So this needs to get memorized. And also the alternative definition, the alternate definition. If y equals some function of x, we say the derivative of y with respect to x at a specific x value, a, some number, is, could also be symbolized f prime of a. It's the limit of f of x minus f of a all over x minus a, where x is approaching a. So we also have to use and memorize this definition. There's two definitions for the same thing, the derivative of y with respect to x. So the easy examples are when the function is a line. If f of x is linear, like 7x minus 4, the derivative is the same as the slope. When an equation is in the form y equals mx plus b, the number multiplied to x is called the slope. And now we're just saying another name for slope is derivative. If a function is linear, negative 5x plus 2, then the derivative means the slope of the line. So here's two quick examples. If f of x is equal to a constant, like 4, the graph of y equals 4 is a horizontal line, and horizontal lines have 0 slope. So if f of x equals 4, the derivative means the slope of the line y equals 4. Horizontal line's slope is 0. Okay. Now we're going to do this example. If f of x equals 1 over x, find the derivative of this function at x equals 3. The words find the derivative of the function at x equals 3 can be symbolized f prime when x is 3. So I know the definition by heart. It's the limit of f of this number plus h minus f of this number all over h as h approaches 0. The derivative of the function at x equals 3 is the limit as h approaches 0. F of 3 plus h, in this example, f of 3 plus h is 1 over 3 plus h. It means this notation, function notation, means put 3 plus h in place of x. Minus f of 3 means put 3 in place of x. F of 3, 1 over 3. We're now going to multiply this green, this blue, and this denominator by 3 plus h. The derivative at 3 equals the limit as h approaches 0. So 3 plus h is the common denominator times the green minus 3 plus h, that's the common denominator, times the blue all over 3 plus h times the black. You can multiply the numerator by the red as long as we multiply the denominator by the same red. F prime of 3, that means the derivative at 3 equals the limit as h approaches 0. 3 times 3 plus h times 1 over 3 plus h is just 3. 3 times 3 plus h times 1 over 3 is just 1 times 3 plus h. All this on the bottom, 3 plus h times h, we just copy that. So what happened here was these canceled. 3 times 1 is right here. Over here, these canceled. 3 plus h times 1 is right here, but there's a negative. On the bottom, we just copy. Distribute the negative. The derivative of the function when x equals 3 equals the limit as h approaches 0 of 3 minus h all over 3 times 3 plus h times h. 3 minus 3 is 0. So the derivative of the function when x is 3 equals the limit as h approaches 0 of negative h, we could say negative 1h, over 3 times 3 plus h times h. And the h up there and the h down there cancel. The derivative of the function at x equals 3 equals the limit as h approaches 0 of negative 1 over 3 times 3 plus h. Because of this canceling. And the limit of this as h approaches 0 is negative 1/9. So that's the answer. This problem could also be done using the other definition. The derivative of a function evaluated at some number is the limit. Instead of h approaching 0, the other definition has x approaching a. And the numerator is f of x minus f of a all over x minus a. And the problem we're doing it again. We're going to find the derivative of the function when x is 9. That was the question. So everywhere there's an a, that's here, and here, and here, and here. All of those are going to be 9s. The limit as x approaches 9, f of x minus f of 9 all over x minus 9. And the function that's given in this exercise is f of x equals 1 over x. The derivative of the function at x equals 9 is the limit as x approaches. Actually, sorry, gotta fix something. The question was at x equals 3. I'm sure you realized I made that mistake. So all of the x's have to be 3's. Fixing the mistake. The question was find the derivative at x equals 3, not x equals 9. So that needs to be a 3, that needs to be a 3, and that needs to be a 3. All the a's are 3's in the question. X approaches 3. F of x minus f of 3 all over x minus 3. So f of x is given, it's 1 over x. Minus, part of the definition, f of 3 means replace x with 3. Look over here, f of 3 is 1 over 3. This time we're going to multiply the numerator and denominator that's above and below this purple line by 3x. F prime of 3 equals the limit as x approaches 3. Common denominator times 1 over x minus common denominator times 1 over 3. And in the denominator, well, if we multiply it above the purple line by 3x, we have to multiply the below the purple line by the same thing. So the derivative at x equals 3 equals the limit as x approaches 3. 3x times 1 over x is just 3, minus 3x times 1 over 3 is just x. And just leave the bottom like it is, 3x parentheses x minus 3. So what we did was we canceled these x's and canceled these 3's. The derivative of the function at x equals 3 equals the limit as x approaches 3. Well, 3 minus x divided by x minus 3 is negative 1. I'll repeat. 3 minus x divided by x minus 3 is negative 1. That's how we end up with negative 1 over 3x. And the limit of this as x approaches 3 is negative 1/9. Same answer we got with the other definition. With two definitions of derivative. Limit as h approaches 0, f of x plus h minus f of x all over h. Using that, we ended up with negative 1/9. The other definition, prime of a, it's the limit as x approaches a, f of x minus f of a all over x minus a. Using that, we got the same answer, negative 1/9. Next one we're going to do is page 103, number 18. On page 103, number 18, this blue graph is given in the textbook. Page 103, exercise 18. The graph of y equals f of x shown here is made up of line segments. 1, 2, 3, 4 line segments. Part A says graph the function's derivative. So these are all linear. Linear means lines, line segments. And the derivative just means the slope. For this first line segment, we're going to go left to right here. The slope is the change in y, that's 2 minus 0, over the change in x, 0 minus negative 4. 2 minus 0 is 2, 0 minus negative 4 is positive 4. So for that first line segment, which starts at starts at negative 4 and stops at 0, the slope is a half. The slope all along here is a half. So we're going to do this over here. I'll use red. So negative 4, 1, 2, 3, 4, up to 0. We're going to make the horizontal line segment y equals a half. At the end of this, we'll make a circle not colored in. The beginning, though, is a regular point. I'll explain this later. So that's y equals a half. It's really y prime equals a half, meaning that's the derivative of that first line segment. When I say the derivative, I just mean the slope. Everywhere along here, the slope is a half. This next line segment goes from 0, 2 to 1, negative 2. The slope is the change in y. That would be 2 minus negative 2, change in y, over the change in x, which is 0 minus 1. The numerator is 4 and the denominator is negative 1. The slope of that second line segment is negative 4. So we're going to graph y equals negative 4. But just between 0 and 1. Just between this x, 0, and this x, 1. 1, 2, 3, 4. This starts out with a hole not colored in, and it ends up with a hole not colored in. So in this little interval from 0 to 1, the slope is negative 4. That's why it's way down here at negative 4. I'll explain why the holes are not colored in later. The next line segment is horizontal from 1 to 4. From x equals 1 to x equals 4, the slope of that is 0 because it's horizontal, or because the change in y over the change in x is going to be 0. Negative 2 minus negative 2 is 0. 4 minus 1 is 3. 0 over 3 is 0. So the slope from there to there is 0. When I say there to there, I mean from 1 to 4. Starting at 1 and ending at 4. This is the slope. It's y equals 0. I should say y prime equals 0. The slope of this part, this flat part, is 0. This last line segment, its slope is the change in y over the change in x. That would be 2 minus negative 2 over 6 minus 4. The numerator is 4 and the denominator is 2. 4 over 2 is 2. The slope of that last line segment is 2. The slope is 2 all the way from 4 to 6. 1, 2. Make a hole there. 4, 5, 6. This dot can get colored in. But this picture right here, these red line segments, they're all flat, is the derivative of the blue. When I say the red is the derivative of the blue, I mean this is showing the slopes of these line segments. Starts out with slope a half, right there. Next piece has slope negative 4. It's very steep. That's indicated here, way down here. The next piece has slope 0. That's demonstrated right here. And the last line segment has slope 2. That's what this last part is at, y equals 2. So the blue graph is y is equal to some function of x. This red thing here, this is y equals f prime of x.